In this lesson, we're going to continue our discussion of the concept of factoring, focusing in on the big ideas of equivalence and properties. If you recall from the previous lessons, factoring is a process that allows us to rewrite algebraic expressions in an equivalent form. It's important that you walk away from today's lesson understanding that some trinomials of the form x squared plus bx plus c can be factored into equivalent forms that are the product of two binomials. It's also important that you walk away from this lesson understanding that the signs and factors of the coefficients of the trinomial indicate how the trinomial will be factored. This lesson is going to focus on factoring the type of polynomial that's called a quadratic trinomial. The word quadratic means that we're going to be focusing in on polynomials that have degree 2. What that means is that the biggest power that we're going to see is 2. We're also going to be dealing or need to understand the vocabulary word trinomial, and that would be a polynomial that has 3 terms. Just as we've looked at in the difference of squares and GCF videos, we want to focus in on how factoring is related to multiplication. So if you look at the left-hand side of the screen, you see a multiplication problem. We have a binomial times a binomial, and if you recall from Algebra 1, multiplying these two things together relies on double distribution. And the acronym that you have for helping you remember how that works is FOIL, first, outer, inner, last. So let's go ahead and multiply these two things together. We would get 2x squared minus 6x plus x minus 3. Combining our like terms, we get 2x squared minus 5x minus 3. The process of factoring a quadratic trinomial is going to let us work backwards and get back to the two binomials that were multiplied together. Let's take a look at how this works on the right-hand side of the screen. We know that our answer is going to be the product of two binomials. Before we focus in on the binomials, though, we want to look at the polynomial and figure out whether or not there's a GCF. The greatest common factor for 2x squared, 5x, and 3 is 1, so there is no greatest common factor for us to factor out. Because there's no greatest common factor, we'll go ahead and put down our two sets of parentheses. The focus in the beginning is really on looking at the front and last terms separately. So let's think about this 2x squared. 2 is prime, so I know that that has to be 2 times 1. X squared I know has to be x times x. So that lets me know that my front term is 2x, and my front term in the other set of parentheses is x. Let's look at the 3 now. With the 3, I know that that has to be 1 times 3. The question comes into play, where do I put the 1 and where do I put the 3? Because one of them is going to multiply by the 2. Well, here's what I know. Because this sign is negative, I know that the 1 and 3 must subtract. And subtract means that they have to use different signs, so one has to be positive and one has to be negative. So what I want to do is I want to kind of either mentally check or write down and check how they would interact with the 2 to subtract and give me negative 5. So let's try multiplying 2 times a positive 1 and then subtracting 3. Well, that's going to give me negative 1, and that's not what I want. What if I multiply 2 times negative 1 and then add 3? That's going to give me positive 1. Again, not what I want. What if I multiply 2 times positive 3 and then subtract 1? That gives me 5. I'm getting closer, but I want a negative 5. So if I do 2 times negative 3 and then add 1, that gives me negative 5. What that tells me is that the 3 needs to be negative and needs to multiply by the 2. So I put in the minus 3, and the reason it goes in the second set of parentheses is because we want it to be able to multiply by the 2 in this 2x. The other set of parentheses gets a positive 1. So the final answer, final factored form here, is 2x plus 1 times x minus 3. You're going to get better and better at these so that you require less and less scratch work. It's important that we talk about the signs of the second and third terms and how they influence the number placement when you're factoring a quadratic trinomial. You always want to begin by looking at the sign of the third term. And if you remember back to the previous example, I highlighted the fact that the third term was negative, and that meant that the numbers had to subtract. If that number is positive, then the numbers have to add. It's important that you note, though, that add means that they use the same signs. So let's say both positive or both negative. And subtract means that they use different signs. Once you determine whether or not you need the same sign or different signs, you're going to look at the second term. So let's say that the third term was positive and the second term is positive. That means both of your factors for the third term would need to be positive. If the third term is positive and the second term is negative, both numbers would be negative. If the third term is negative and the second term is positive, the larger product must be positive. But if the third term is negative and the second term is negative, the larger product must be negative. And that's what we saw in that previous example. We needed them to have different signs, but since we had a negative b value, we needed the product of 6, the 2 times the 3, to be the negative piece. Let's look at 2 more examples. Here we want to factor 3x squared plus 14x plus 8. Is there a GCF? No. So I know that I'm going to have 2 sets of parentheses. 3x squared is prime, so I know that that has to be 3x times x. 8, though, is interesting. I can do 1 times 8, or I can do 2 times 4. The question now is going to be figuring out how they work together, all right, or which pair of factors I need. Because the third term is positive, I know that I need to use the same signs. And because the second term is positive, I know that both signs need to be positive. So let's mess around with the different options. We'll look first at the 1 and the 8. Let's try 3 times 1 plus 8. That's 11, but my b value is 14. What about 1 plus 3 times 8? Well, that's 25. What that shows me is that I can't add the numbers together with one of them multiplying by 3 to get 14 if I use factors of 1 and 8. What about the 2 and the 4? Let's test those. 3 times 2 plus 4. That's 10. What about 2 plus 3 times 4? That's 14, and that's the combination that we want. So what this shows us is that the 4 has to multiply by the 3, so it's going to go in that other set of parentheses. We know that they both need to be positive, and that means that the plus 2 goes over here. The final answer here, factored form, is 3x plus 2 times x plus 4. If you recall back to the difference of squares video, one of the things that I highlighted is the fact that the first thing that you always do when you factor is look for a GCF. If you look at the problem here on the right side of the screen, there is a GCF here. The GCF would be 2. We factor out that GCF using division, and we'd be left with 5x squared minus 11x plus 2. We now need to look at that quadratic trinomial and determine whether or not it can be factored. I recommend that you pause the video now and try factoring 5x squared minus 11x plus 2 on your own. We already took out the greatest common factor, so we're going to leave a 2 outside and then set up 2 sets of parentheses. 5x squared is prime, so that means that I'm going to have a 5x times an x is the leading term in each set of parentheses. 2, we know, has to be 1 times 2. The third sign here is positive, so that means I'm going to use the same signs, and I want them both to be negative. So let's just figure out which one of these has to multiply by the 5 so that we get 11. 5 times 1 plus 2, or 5 times negative 1 minus 2, would give us negative 7. That's not what we want. What about negative 1 plus 5 times negative 2? That would give us negative 11. That means that I need to put the minus 2 in the other set of parentheses so that it can multiply by the 5, and then minus 1 in with the 5. Factoring quadratic trinomials can be a difficult concept. It's something that's very abstract. I recommend that you highlight any questions that you have in your notes, and we'll do some more examples when you get to class.